Okay, welcome to the next video in this series. I'm doing the AQA Gcse specifications. Now, we're in electricity. I'm now going to be looking at current and charge, but specifically at this equation here. Now, what is this telling us? I stands for current, and a lot of confusion. There's a lot of potential confusion among students here, because notice the letter I, which is the symbol for current, is nowhere to be found in this word current here. Okay? Additionally, the unit for current is the ampere or amp, so capital A, and the letter A is not found in the word current either. So you've just got to remember that I is the symbol for current and A or amps is the unit for current. Likewise, Q stands for charge. Again, Q is nowhere to be found in that word there. And also, even more confusing, its unit is the coulomb, capital C. Okay? This is due to the fact that not all scientists are English, so we've got to be a bit flexible with our symbols. Okay? Right. T stands for time, and units is seconds. This symbol here is just the Greek letter delta, which is the change in time. And what this equation is telling us, well, current is a measure of the amount of charge passing a point in a certain time period. Okay? So let's write that down. Current is the definition. It is a measure of the rate of flow of charged particles. Okay? Measure the rate of flow of charged particles. And remember, one of my earlier videos, I talked about this symbol here, the ammeter. The ammeter does this. It measures the amount of charge passing a point per second. Okay? So, for those of you who aren't good at rearranging equations, I'm going to redraw this, put this into a pyramid or triangle, something that you may be a bit more familiar with. So, if you're going to do a triangle equivalent, it would look something like this. And for those of you who don't know how to use this triangle, if I want to work out current, I cover up this I, so I'm left with Q on the top and T on the bottom. This line here stands for divide, so it's charge divided by time. If I want to work out the time, it's charge divided by current. If I want to work out my charge, it's current times time. Okay? So that's how you use this triangle, all that equation, and if you're good at maths, just rearrange it depending on what they give you in the question. Okay, so let's just do a worked example quickly. Let's say I want to work out the charge, so Q is what I want to work out. My current is 10 amps, my time is 10 seconds. So Q, I cover up Q, I times T, 10 times 10. So Q is 10 times 10, that's 100 coulombs. Okay, let's do one more example where we've got to divide. Let's say I want to measure the current this time, and I have 40 coulombs, and it goes past the point in 10 seconds. What's my current? Well, cover up I, it's Q divided by T, so it's 40 divided by 10, and that is 4 amps. Okay? Hopefully that's helpful to you. I'll just quickly go over some prefixes as well. Sometimes, and this is particularly if you're doing a higher paper, you've got to be able to convert units. So, a kilometer is equal to 1,000 meters. 1 millimeter is equal to 1 times 10 to the minus 3 meters. 1 centimeter is equal to 1 times 10 to the minus 2 meters. Sometimes you might see this symbol here, which stands for a micrometer. It's like a weird U. Okay, it's 1 times 10 to the minus 6 meters. If I go the other way, 1 megameter, so capital M, is 1 times 10 to the 6 meters. That's 1 and 6 zeros after that. And I could go to 1 gigameter, which is 1 times 10 to the 9 meters. Okay, so notice I've used meters, but these M's could be changed to A's, amps. So I could have 1 kiloamp, 1 milliamp, 1 centiamp, and so on. Okay? And the reason why I've given you these conversions is because when you do your calculations, you always want to have it in SI units. So for distance, we always want it to be to have our answers in meters, not these prefixes here. Okay? So hopefully that's useful, and don't worry, I'll do some examples of these in later videos. Hopefully that's helpful.